Hey everyone, welcome back to the lab. In this video, we're going to be talking about F-sharp-like records in Python and how to get them. So F-sharp has some of the best programming ergonomics of any language, any programming language I've used in my software engineering career. A large part of this is due to its excellent type system and core data structures, allowing for expressive, precise logic declarations with minimal boilerplate. I liken writing F-sharp to writing in bullet points, whereas other languages are more like full-on prose. And this is the best metaphor I think I've come up with for when people ask me why I like F-sharp. And I get that question pretty often. I'll probably do a video on it to kind of go deeper into it. But really when I talk about ergonomics and stuff, it's that I can basically code as if I'm writing in bullet points, which is what I do anyway with like regular English. And so being able to do that in code gives you those same like superpowers, if you will, making things way simpler, easier to follow, without all the fluff that you might need in other languages to describe what you're trying to do. Anyway, back to this post. The problem is that you don't always get to choose what language you use at work, where a lot of your coding is likely to happen. Getting the same amount of expression and precision in other languages, besides F-sharp, can be quite hard. Python has been a primary language at companies I've worked for over the last 5 years of my career. This is Rippling, where I am currently, Reddit, where I was previously, and then Instagram, where I was for 3.5 years, all use Python as a major part of their tech stacks. And so in this post, we're going to explore how can we get F-sharp-like records in Python. All right, here's the TLDR answer. Python data classes utilizing the frozen and keyword-only flags allow us to get similar expression and precision as F-sharp records. We can use data class to provide a lean construct for holding records or holding data that's mostly groupings, and this is basically what records are in other languages like F-sharp. Frozen allows us to make the data class immutable, which is something we get by default in F-sharp records, and then keyword only enforces the creation by field name, which we get by default in F-sharp for most things, records included, but Python doesn't. So if you want to end here, this is basically what I want you to take away from this. The F-sharp records is basically creatable in Python using this data class with the frozen and keyword only params, and you can see here that you can list fields and their types like you would any F-sharp record. So for a deeper dive into what these do and why this is so important from a Pythonic or dynamic language point of view, you can read my last blog post. I also have a video on this, on Python data class best practices and why you should use them. The difference in this post and that post is really coming from like the Python dynamic standpoint of like you don't care about types and I need to tell you why you care about types and give you a whole bunch of examples. This one is a little bit shorter, more just like, hey, you like F-sharp records, but you're forced to use Python. How can you kind of accomplish the same goals with the same tools? So in the rest of this post, we're going to explore the basics of how F-sharp records work and how Python data classes compare. You can run all included examples via these replets. Yeah, I've been using replit a lot to kind of make sure that you know that this is real code and you can run it and stuff. And so I'll have this linked below, but you can also find them here in the blog post. Okay, F-sharp records versus Python data classes. F-sharp records and Python data classes both attempt to solve similar problems, making it easy to group data together and operate on them. This is a very common practice in any software system, as at some point you'll want to group related data together, often with subcalculations or several inputs to subcalculations. I think as soon as you start going functional, so anything like pure functions without side effects, you're going to end up with doing this. And if you're not going functional, you might think this is wrong because you've never had to do this, but you actually are doing this with all those side effects on objects and stuff. So if you want to get away from side effects and get towards like more deterministic, easy to understand code, you're gonna need these little groupings of data. F-sharp records have several defaults that make them very nice to work with, and I think this is one of the big reasons why F-sharp has those great ergonomics, is because the type system is excellent at expressing your things, and then the actual data classes or core data structures that you use for the most part to model your domain using those types is also very easy to use, records being one of the big ones. And the reason being is that first it allows you to do value-based equality, which is going to be very weird to people coming from object-oriented land where they're used to, you can't, ask if an object's equal to an object. You need to build like a self-comparator. It's kind of like a code smell in object-oriented programming. And in functional programming and really data-based programming, this is much more common. And intuitively, this makes more sense, right? Like when we ask if two things are real or equivalent in the real world, what we're asking is like, are their attributes equivalent, right? Is this duck the same Right, when we ask, like, is this duck the same as this duck? Like, we could mean ID, but for the most part, what we're asking is, like, is it the same species? Is it the same color? Is it the same height? And stuff like that. That's what we're actually asking in most equivalents. That's not, like, specifically, is this the same person, if that makes sense. The second thing it gives us is immutable by default. I think all principles try to get you to go towards immutable, so this makes sense. And then explicit field-based construction, which I didn't actually realize was a useful thing until I saw the way that Python's data classes were doing it, and then I was like, oh, we need this. Okay, so here's a simple record that I have the code here, but I'm just going to switch over to our replit to kind of show you. So let's make this bigger. Let's close this stuff. And then so on the left here, I have the replit code. Let me make it bigger. And on the right here, I have the output. It's a little bit smushed as a small screen, but I'll try to make it as easy as possible. And so I'm just going to run it real fast just so you know that this is the real code that I'm running. Okay, and here's the output. And basically what I have here is just a simple type. This is how you, or a simple record. This is how you would define it. So it's just got two fields, a string field and an int field. And then here in the main, we will actually create it. So here we are in example 1. And the way that we actually instantiate this is very similar, right? We just say for every field, we're gonna set it to something that is compatible with its type. And then I can print it out here. And you can see that we've created this record and the fields and values are set. Now, while we're at it and talking about records, I also want to show you some of the defaults that it has. So here we can check that it's value-based equality. So I've created another record, which is the same as the previous record. You can see that a string is I'm a string, and then bint is just equal to 1. So they are value-based equivalent. And so when I ask if, hey, is my simple record equal to simple record 2, and the equal sign is the equivalent sign in F#, we can get out true, and that's how we know that we must be doing value-based equivalence because it's not the same instance, but it's the same value. And I can show you the opposite here where we create simple record 3, and we just set string to something different here, and we ask if they're the same, and we get false back because they're not the same. Now, while we're at it, I also wanted to show you immutability, and I have to uncomment this for this code to run because, you know, we're a compile-based language. So theoretically, we will usually see something in our type checker here, but maybe this is running slowly. So I'll just run this to show you what happens. So here I try to build this, and this is failing at the build stage, and basically it's saying, hey, I got an error, this field is not mutable. And so we know that this fails, and so we never get a runtime error for this. This is actually built into the type system. It is immutable. You cannot do this. And so this whole thing will fail to build, and so before you ship to prod, this is blocked. And usually this will be shown in the error as well. I don't know if replits like IDE-based linting is just not working or whatever, but this is a build time error here. And we'll talk about this a bit later as well and why this is important. Okay, so that's your quick overview of F# records. Okay, so Python's data classes don't give us quite so many things out of the box. They give you value-based equality, as I showed you earlier, which again is probably different than the way that Python's regular classes work. But we're missing two important things. So immutable by default we're missing, and explicit field-based construction we're also missing. So here's a quick example of that, and I'll move over to the replit to prove that this works. Okay, so let me run this to prove that this is the code we're actually running. Just ran here, and we're talking about example 4. And so here it is, data class equality. So we're basically doing the exact same thing like we did previously. So we just have this simple data class. It's got a string field, it's got an int field, and we're creating A and B here. These are the same, and then we're creating C, which will be different. And so now we're asking, hey, was A equal to B? And we check it here, and it returns true. So we can see that we're doing value-based equality and not object ID-based because these are actually different instances. And then we ask, hey, is A equal to C? And we get false, which is proving that if the values are different, then it's not the same. So it gives you that value-based things, but we're missing immutability, and we're missing the explicit field construction. So how do we get that? And luckily we can extend Python's data class to get that. All right, so we'll start off with explicit field-based construction. So while Python's data classes may seem a lot simpler and less verbose than F#'s records based on the examples above, I'm here to tell you that's often not what you want in large projects. Here we can harken back to the zen of Python's explicit is better than implicit and realize that the simple syntax usually leads to complex code with large amounts of parameters, usually at 3 or more. So basically what I'm saying is when we start getting these groupings that are 3 or more parameters, and usually you'll only be using records when you have like 3 or more things, then this starts to get confusing. And here, like, just by itself, it doesn't look that confusing. But if I quickly show you the Python data class best practices, we have all sorts of other examples where this is very confusing. So even with 3 parameters, when we're down here, it's very confusing to see what do all of these actually mean, and it's very easy to get something wrong. But if you just assume that this is important, because we're trying to get F#-like records here, basically we can enforce explicit field-based data class creation by utilizing the keyword only parameter. So I'll show you example 5 here. So basically all we have to do is we pass this keyword only to our parameter, and you can see it's basically the same, just a string field and an int field. And now, in order to actually get this to work, we have to provide the fields explicitly that we're trying to set this to. And this solves a whole bunch of bad problems. Yes, it might be hard to read when you have a lot of them, but also because this is order-based setting, when you've got all these parameters, it keeps you from having that problem where someone moves the order of the properties because they don't know about this data classes, and now you're setting the wrong thing to the wrong thing all over the place. Now this should also give us an error. So yeah, okay, the linter for Python's running a bit faster, and so it's telling us here that, hey, there's a problem here. The linter is saying you can't do this because it expects keyword only. Now this is the thing about dynamic languages though, is I can still run this and everything will work splendidly until we hit this error, and now this is a runtime error. So we're still not getting the build time errors that we could with F# because it's like built in, statically typed, compiled. But we are getting at least build time errors in the sense of if your IDE is catching this with the linters that it's running. So still better than not having it at all. Yep, so trying to construct a data class with keyword only equals true without explicit field names will throw a runtime error, and most Python type checkers will surface an error allowing you to catch at build time as well. And yeah, this is most Python type checkers, just depends on yours, some just aren't that good. Okay, immutability. So F# is a functional first language, which means it leans heavily on functional programming principles while allowing you to code more imperative should you wish. Immutability is a principle that largely leads to more robust, easier to understand code. Python does not do this. It's dynamic and mutable by default, but we can force some level of immutability into these data classes using the frozen equals to true parameter. This will cause a runtime exception when you try to mutate data class, and most type checkers will surface an error allowing you to catch at build time as well. So let me show you example 2 from our Python guy. Okay, so immutable data classes. What are we doing here? So we have a mutable data class here, and basically we can show that we can do a bad mutation on it. And we show this by saying, hey, before mutation we had a 1, and then after mutation we were able to set it to 0. But now we're going to create a data class which is the exact same, but now it's immutable because we're setting frozen equals to true. And so we have this bad mutation function where we pass in the data class and we try to actually change it. Now we can see here that we are getting a squiggly. So this is kind of a build time error if you pay attention to your editor squigglies and your linters working. But again, because this is actually a dynamic language, what we can do is uncomment this and run it. And now we see that what could have been a build time error is now a runtime error. We have before mutation here, it's immutable DC. And then we try to actually do that mutation here and we fail at runtime instead of build time. But again, at least it fails. And you can catch this in the editor, hopefully, but definitely at runtime, which will at least prevent these semantic errors from happening way down the line. Yeah, so F# is my favorite language, but I've yet to be able to use it as part of my job. Luckily, it's taught me a lot about what's possible and improved my standards for what I accept as sensible in other languages. Seriously, the ergonomics are so good that I didn't know what I was missing until I learned kind of the functional side of things, and now that I know what's missing, when I go to other languages, I'm like, wow, people think this is fine. It's actually not fine. We can do better. On further investigation of other languages, it seems we can often approach some of these common sense principles. We just might have to dig around in their available libraries and buck some common trends. Yeah, I think a lot of Pythonista people won't like this. A lot of people from dynamic languages will say it's like too verbose and stuff. But my argument is basically that there's a bit of each that we like. Like we like the non-boilerplate of dynamic languages, but we love the robustness and correctness that we get from static type languages. And there's this place in the middle where we actually get all the power of the static typing with none of the boilerplate. And that's where we want to be, and that's where F# really shines. And I think both sides can learn from that and kind of get to the better place. Hopefully these tips will help you write simple scalable systems in Python. They've helped my team at work, so hopefully they can help you as well. If you like this post, I would definitely recommend doing the Python data class best practices. This is the exact same thing, but way more from the dynamic and Pythonista side of things. So if you're one of those, probably read that, and this will hopefully make more sense. If you're here, you probably like F#. I was formatting F# wrong for years, so definitely check out this post to make sure that you're not doing that. And then if you're trying to get into just practical F#, you can check out this post, web scraping with F# and Selenium. That's it for this video. Thanks for watching, and I'll see you in the next one.